Hello dear students, this is Mr. Muhammed Azeez. Previously we stopped right here and now we are going to solve some questions about distance. Distance is a very common idea in optimization. What should we find? We need to find the shortest distance. Reading the question says find points on the parabola, that's a given function, that are closest. Closest means shortest distance or minimum distance. That is optimization to the point 0, 2. Since I want minimum distance, I need to write the rule of distance and then derivative after that equals 0. Find x. Let's solve this question. All right, here, this question. I want shortest or closest, that's shortest distance. I start by writing the rule of distance. Rule of distance is like this, x square root x2 minus x1 squared plus y2 minus y1 squared. And if someone writes like y1 minus y2, then they just have to write x1 minus x2. Doesn't make any difference, the rule is still distance. I wrote it like this. Now, one xy that we know is this point, 0, 2. The other one is a point, xy, which we don't know. Okay, now let's put these 2 points in this rule. Distance equal to square root x minus 0 squared plus y minus 2 squared. All right. Now, x minus 0 is just x. Now I have distance equal to x squared plus this side, we need to replace the y. Distance should contain only x or only y. Then I can do derivative equals 0, then I can find minimum. Here, in the question, what's given is this. fx equal to 4 minus x squared. And we all know fx means y. Y equal to 4 minus x squared. Just replace this y with 4 minus x squared. Then we will have distance containing x only. Simplify, then derivative equals 0. Instead of y, I write 4 minus x squared, and then minus 2 all squared. Still distance. We do not move to the derivative yet. As far as we simplify distance, the derivative gets easier. Now, x squared is the same. 4 minus 2 is 2, plus 2 minus x squared power 2. We have these two numbers. These are both numbers. Positive 4, negative 2. When we add them, we get positive 2. And the negative x squared stays the same. Now we have to expand this bracket. This bracket needs to be expanded. Distance equal to x squared plus theorem 1 power 2 is 4. Theorem 1 times theorem 2 times 2 is negative 4x squared. Theorem 1 times theorem 2 is negative 2x squared times 2, negative 4x squared. Theorem 2 is negative x squared power 2, it becomes positive x power 4. Now we have like terms. As I said, as far as we simplify the distance, the derivative becomes easier. Now x power 4, we can write it in the beginning, and then negative 4x power 2 plus x power 2, that is negative 3x power 2, and plus 4. To make this question easier, look at this strategy. All you have to do, that's like a shortcut, but it is a good shortcut. It works all the time. Take the derivative of inside equals 0 only. Don't do a normal derivative of square root 2 square root goes down, derivative of inside goes up, then equals 0. We just solve numerator. From here, just take the derivative of inside the radical. Derivative of inside is 4x power 3 minus 6x. And then derivative equal to 0, both divisible by 2. 2x power 3 minus 3x equal to 0. Now take x as common factor. X, what's remaining? 2x squared minus 3 equal to 0. Between x and the bracket is multiplication, so we get the first solution, x equal to 0. This is the first solution, but this is not going to be minimum. Minimum is from the bracket. Now I solve the bracket. 2x squared minus 3 equal to 0. Send 3 to the other side. X squared equal to 3 over 2. X equal to square root 3 over 2 positive negative. X power to always have two solutions. X power to always have two solutions. Then one of them is radical 3 over 2, positive, and the other one is negative radical 3 over 2. That's cool. This question is complete. These are minimum. No need to do the table as well. This table I did it here to show you that these x's we found are definitely minimum. See, this is minimum. This is minimum. This question is complete. Now we have 3 more questions about distance. Kind of, they all have the same idea. All of them. Let's do question 5. Again, the question says find the closest point or shortest distance. Question 5. Let's begin. Again, we have 2 points. One of them is xy, unknown. The other one is 4, 0. Let's write the rule of distance for these 2 points. Square root x minus 4 squared plus y minus 0 squared, which is just y squared. Now I'm going to replace y with radical x because it's given fx equal to radical x. And everyone knows fx means y. So y equal to radical x. Replace y with radical x. I'm going to get d equal to, expand this bracket, x squared, first times second, negative 4x times 2, negative 8x, plus 16. And on the side, we will get like radical x power 2. Radical and power 2 cancel out each other. What's remaining is only x. Simplified, x squared, negative 8 plus x is negative 7x plus 16. Now take derivative of inside, 2x minus 7 equal to 0, x equal to 7 over 2. That's it. When x is 7 over 2, if I want to find y, put x back here, y equal to radical 7 over 2. So as point 7 over 2 and radical 7 over 2 is the shortest or the closest point to the point for 0, which is on this graph. This question have been in Wizari once, and the answer, the multiple choices were like points, and that was the right answer. That was in the choices. Another question about distance again. Okay, we already got the idea. Let's go through the steps. Here we have fx equal to x plus 1 squared. The point is negative 1, 3. Now let's begin. We're going to write the rule of distance between xy and negative 1, 3. This is like this. X minus negative 1 power 2 plus y minus 3 power 2. Minus minus will be plus, and this is the same. Now, the replacing this time is different because we already have x plus 1. This x plus 1 all power 2 is already here, x plus 1 all power 2. So I can just replace the entire bracket with y, and I'll get the distance in terms of y only. So y equal to x plus 1 all power 2. Replace, instead of x plus 1, I just wrote y plus y minus 3 power 2. Expand this bracket, y power 2 minus first time, second time 2, negative 6y, second squared plus 9. Now, organize it. Take derivative. This is square root, so to find derivative, we can use the rule of square root. But as a shortcut, take derivative of inside only, equal to 0, and solve it. What will we get? Y equal to 5 over 2. That's it. This is the value of y. Y equal to 5 over 2. This note made this much steps, one step. We got y equal to 5 over 2. Now to find x, put y back into the function, the given one. Fx equal to x plus 1 all power 2. Fx means y. Put 5 over 2 that we just found in place of y. And then to remove power 2, take square root to both sides. On the side, square root appears, and on the side, power 2 gets cancelled. The square root part gets positive negative because power 2 has two answers. Then send one to the other side. These are the two possible values for x. X is positive radical 5 over 2 minus 1, or x is negative radical 5 over 2 minus 1, while y is the same, because this single y we solved, we found two different x's for it. So there are 2 points that are too close to the given point, negative 1, 3. This question, again, it's about distance. As I told you, distance is a very common idea in optimization, and distance have been in Wizari a lot. We had 2 examples and 2 exercises. That's 4 questions, same idea. Let's do this. What do we have? We have a point 0, negative 1, and another point xy. xy, 0, negative 1. Write the rule of distance for these 2 points. Distance, x minus 0 is just x squared, plus y minus negative 1 will be y plus 1 squared. We can replace y with x squared minus 2. That's totally fine to do. Or there is another idea. We can apply it for this question. I can recreate x squared minus 2 by writing minus 2 plus 2. This whole x squared minus 2 becomes y. Then I have distance equal to y plus 2 plus, expand this one, y squared minus 2y, not minus, plus 2y plus 1. Simplify, distance equal to y squared plus 3y plus 3. Take derivative, 2y plus 3 equal to 0, y equal to negative 3 over 2. We found y, let's use y to find x. Negative 3 over 2 equalize it to x squared minus 2. Negative 3 over 2 equal to x squared minus 2. Send negative 2 to the other side, becomes positive 2, and negative 3 over 2 is like negative 1.5. Negative 1.5 plus 2 is positive 0.5 equal to x squared. Take square root, so we get positive negative square root 1 over 2, or square root 0.5 equal to x. These are two possible values for x, and we already have y, so this y and each of these x's make 1 point. That means we will have 2 points in total. Or we can use this way. That's the same way we used. Yeah, y is negative 3 over 2, and x is positive negative radical 1 over 2. Radical 1 over 2, we can write it as radical 1 over radical 2, and the positive negative stays. Radical 1 is equal to 1. The positive negative stays, but radical 2 cannot be simplified, and we don't like decimal for such questions because the multiple choices won't be decimal. If you had no way you can change this to decimal, change the multiple choices to decimal as well using calculator and compare, see which one is the exact same number or which one is the closest. Finding the box of greatest volume. For this question, I'm going to show you a way that is not a complete fast way, but it's like a shortcut that works all the time, and the shortcut is quite scientific. Whenever you see this open box question, straight away write 3x squared. This is the key. 3x squared. Directly, whenever you see this open box question, this one, we have two open box questions. Each one have different ideas and different given. When you see this open box question, surface area is given, then directly write 3x squared and equalize 3x squared to 675. This question have been in Wazari. Once they asked for x only, and once they asked for height. X is length and width. Both are x, because the open box has a square base. Let's solve this to find x. Divide both sides by 3. So x squared equal to 675 divided by 3 is 225. Take square root, x equal to 15. Now you might wonder why not positive negative 15. X represents length and width. Length and width cannot be negative. Only positive is accepted. So x equal to 15. Directly, if they asked for h is always half of x. In order to have the maximum volume happens, this is the relation between x and h, if h is half of x. Now x is 15, so h is 15 divided by 2, which is 7.5. We can just ignore this way and follow these 4 steps I wrote. Now go to the last page of chapter 4. There is this question, the Wazari form of it. Let's do it. Last page, there is the question. Same question, even the diagram is given, but the surface area is different, which is okay. And they ask for x. The question says find x. Okay, what was the key? 3x squared. Always, when you see this open box question, write 3x squared. 3x squared equal to 432. Now divide both sides by 3. X squared equal to 432 divided by 3 is 144, but we don't have time for silly mistakes. 432 divided by 3 is 144. And then take square root x equal to 12. As I said, why not positive negative 12? Because x represents length and width of the box, so x must be positive. X equal to 12 is option D. There is another way, which is very easy, but it's not quite functional in the exam. But the way works for this question. Look, you see question 17 here, right? In the answer key, look at question 17, and immediately you know the answer is D. But this way doesn't work in Wazari exam. This way does. I'll come back. Now let's go and study the other open box idea. Optimization means sit and solve. No other way can heal the damage that optimization did to your mentality and your psychology, your self-esteem, your confidence. Okay, the other open box question is like this. An engineer wants to design an open box, again, that is made from a square piece of metal. When we have one square sheet of metal, that's the other open box question, okay? The previous open box question was like an engineer wants to design an open box having maximum volume. with square base and surface area was given. Here surface area is not given. And it is saying by cutting equal squares. This is the key expression to distinguish between the first open box question and this second open box question. Here we have a square piece of metal, which is 24 by 24. After we cut out the x's, see, these little squares here are the x's that have been cut. So if the whole length is 24, after we cut out two x's, then what's remaining from here until here is 24 minus 2x. This diagram will be given as well. Look at the 3D version of it. After folding it up, after the cutting, this height is x, the height of the box. And these two are equal because the question says square piece. This is 24 minus 2x, and this one is also 24 minus 2x. What makes this question easier than the previous one, when I write a formula for volume, volume is length times width times height. So I can write 24 minus x multiply by 24 minus 2x. There's a 2. 24 minus 2x multiply by 24 minus 2x, that's 24 minus 2x squared, multiply by x. This is the volume, and we want this volume to be maximum, then we just have to take derivative equals 0. Why? Because the volume already contains x only. There's no any other variable to remove or to substitute. We can directly take derivative equals 0, solve, find x. Or you can ignore all of these and just divide the side length by 6. We directly get x. That's the fast way. 24 is given. If we divide it by 6, we will get x. The 6 is fixed. The 6 is fixed. If they change the side length to 36, let's say, you just say 36 divided by 6 equal to 6. That 6 is x. And such questions, when come back, they just ask for x. Wizari questions are clearer. They are way clearer than the exercises. 24 divided by 6 is equal to 4. So x equal to 4. If x is 4, then put 4 here. Find volume. Volume equal to 24 minus 2 times 4, 8, power 2, multiply by 4, x is 4. 24 minus 8 is 16. Now, we have the volume 16 power 2 times 4. 16 power 2 times 4. Result 1024. Now, the moment of truth, after all of these steps, final answer is 1024. That's brilliant. But if you really want to solve, we found until here the volume, expand the volume, simplify it. After simplifying, find derivative, and then derivative equal to 0. When we equalize to 0, we will have two brackets to solve, and we will get two x values. One of them is 12. The 12 will be rejected. Why? Because side lengths cannot be 0. I have the side length 24 minus 2x. If I put 0, not 0, if I put 12 in place of x, 2 times 12 will get 0. Side length cannot be 0. This is why this x equal to 12 is rejected. X equal to 4 is accepted. Now put 4 back into the formula of volume. We will get the 1024. That's quite smooth. Next question is the farmer question. For this video, we stop right here. Hopefully, we're going to continue very soon. Thanks for watching.